So in this video we're going to be drawing a velocity time graph. The points A, B, C lie on a straight line in that order. Right, let's draw ourselves a diagram so we can visualise what's going on. Here's my straight line. A, B, C. A person starts at point A at rest. They accelerate uniformly for 5 seconds to a speed of 4 meters per second when they reach B, and then decelerates uniformly for 3 seconds back to rest at C. So they're starting from A, they speed up to a maximum speed at B, and then they start to decelerate, getting slower and slower and slower until they're back to rest at C. The person then reverses direction and accelerates uniformly for 8 seconds when they pass A. So essentially they're going to reverse direction and then they're going to be slowly increasing speed until they reach A. And they're going to be increasing speed for 8 seconds. Draw a velocity time graph of the person's motion and determine their speed when they pass A on the return trip. Okay, so let's start drawing a diagram so we can see what's going on. Okay, so you'll notice I'm readying for a negative velocity here because we're going to be travelling for some portion of this in the reverse direction. So we're going to be taking this direction to be positive and this direction to be negative. Okay, so this is time in seconds, and this is going to be velocity in meters per second. And this is, of course, 0. So the total amount of time, we're going to have 5 seconds, then 3 seconds, that's 8 seconds, then 8 seconds to get back, so 16 seconds. So this total here, that's got to be 16 seconds. Okay, so to give myself a little bit of an idea, so I'm not going completely overboard, let's try and do this reasonably accurately, shall we? So if I do, what do I want? Well, let's do it like in centimetres, shall we? So, no, let's do it 16. So 1, 2, 3, 4, 5, 6. So somewhere about there. So that could be 8. And then 1, 2, 3, 4, 5, 6, 7, 8. No, we need 32. Let's say about there, right? So let's say that's the first 8 seconds. And that's the second 8 seconds. Let's go with that. Okay, so first of all, they accelerate uniformly for 5 seconds to a speed of 4 meters per second. So they reach 4 meters per second in the first 5 seconds. So somewhere around about here. So that could be 5. So this is the first part of the graph. So it's a straight line because it's a constant acceleration. The acceleration is uniform. And then they decelerate uniformly for 3 seconds back to rest. So that's that portion of the graph there. Okay. The person then reverses direction and accelerates uniformly for 8 seconds when they pass A. Okay, so it takes 8 seconds for them to get back to point A. So they're going to be accelerating in the negative direction for 8 seconds. Ooh. Let's pop that. Okay. So, this is what the graph will look like. So at this point, they reached a stop. Okay, so we're at rest again at 8 seconds. Once you're on a velocity time graph and you're going in the downward direction, okay, that means you're now accelerating in the negative direction. So we're accelerating in the negative direction, getting faster and faster and faster, going in that direction. And then we know that we reach point A after 8 seconds. The only thing I don't know is how fast I'm actually going when I reach point A again. That's this last bit of the question. Now, what I said before in the introductory video to kinematics here is that when you're looking at a velocity time graph, in order to work out displacement, the area between the line and the time axis is what you want to look for. So, the area of this triangle here will tell me the distance from A to C, or the displacement from A to C. If I could work out that area, then this triangle's area and this triangle's area would need to be the same, because I need to cover the same amount of distance, right? If I know this triangle's area and I know its length here, I can work out this length here. That's my route through. So first of all, let's work out the area of this triangle. So the area here is 1/2 times the base, which is 8, times by the perpendicular height, which is 4. So 1/2 times 8 is 4, times by 4 is 16. So that's 16, and that would be meters. So it's 16 meters is the displacement, which is 16 meters to get from A to C. So that means that this triangle needs to have an area of 16. So if the area is 16, that must be 1/2 times by this distance here, which is 8, times by this distance here. So let's call that x. Okay? So, if that's the case, then we've got 16 is equal to 4x, divide both sides by 4, and so x must be 4. So that must mean that it must reach a velocity of -4 meters per second, or the speed when they pass A must be 4 meters per second. Okay? So they travel for 8 seconds from C to A, and by the time they reach A, they're traveling at 4 meters per second.